On example 5, we're going to graph with transformations, and then we're going to state the domain of the range. So once again, I think I'll make my table. So I'm going to have x and 2 times 1/4 x plus 2 minus 3. So I'm going to put in when x is negative 2, because that's when it makes up my exponent 0. So I'll put in a couple numbers, negative 3, negative 4, negative 1, and 0. So when x is negative 2, negative 2 plus 2 is 0. 1/4 of the 0 power is 1. So 2 minus 3, well, that would be negative 1. Let's put in negative 3. So if I go negative 3 plus 2, that's negative 1. So take the reciprocal, I get 4 times 2 is 8, minus 3 is 5. And I'll put negative 4. So negative 4 plus 2 is negative 2. So 1/4 squared would be 16. Do the reciprocal, so it's 16. Times 2 is 32. Minus 3 is 29. That's going to be way off my graph right away, isn't it? Let's put negative 1 in. So negative 1 plus 2 is 1. So we take 1/4 of 2, which is a half. Half minus 3 would be negative 2.5. Let's put in 0, my y-intercept. So 0 plus 2 is 2. 1/4 squared is 1/16. So 2 divided by 16 is 1/8. So I'll get like negative 2 7/8. So what happens here, let's draw a graph here. I'm not going to go out to 4 because 4 is really big, but I'll do the others. So I'm going to start at 0 and negative 2 7/8, because notice you got a transformation here. Oh, my pen just died. Very good. We got a transformation here because it's down 3, isn't it? So this minus 3 is my vertical translation, so I'm going to slide it down 3. So my asymptote is going to be at negative 3. So what I'm going to do is I'm going to go down here. I'll make my graph. So here's negative 1, negative 2, negative 3. So it's asymptotic to negative 3. When you're at 0, you're at negative 2 7/8. When you're at negative 1, we're going to be at negative 2.5, which is pretty much there. When you're at negative 2, I'm going to be at negative 1. When I'm going to be at negative 3, I'm going to be at 5. And then when I'm at negative 4, I'm really off the graph up here at 29. So my graph looks like that. And notice it has a horizontal shift of 2 to the left, isn't it? So your domain, my domain is still all real numbers. That's always going to be the case, because you can put any number in for x you want. But your range starts at negative 3, doesn't it? So I'm going to say for my range, y is greater than or equal to 3. Now let's take a look at a graph on technology so it looks a little bit nicer. And I think I plugged this in, but I think I put a minus sign instead of a plus sign. So let me change that to a plus sign. And now we can see it. And let me shift that in so you can see it. So we can see it's been shifted over 2 units. And then it's also been shifted down 3 units. And there you have it. Now let's take a look at example 6. It says the pressure of the atmosphere is 14.7 pounds per square inch at the Earth's surface. It decreases. This is a little bit different now. It decreases. So that's going to be exponential decay by about 20% for each mile of altitude up to 50 miles. Draw a graph to represent the atmospheric pressure from an altitude from 0 to 50 miles. So the only difference between exponential growth and exponential decay is when you do exponential decay, it's going to be your initial amount times, instead of saying 1 plus r, I'm going to say 1 minus r and raise that to the t power. So I'm going to start with 14.7. And I'm going to go 1 minus 0.8 to the, whoops, got ahead of myself. My brain went ahead. 1 minus 0.2 to the t power. Now I want to simplify that. So 14.7 times 0.8 to the t power. Now I'm going to graph this with technology, but I think what I'll do is I'll make my table so I know where I should start at. So I'm going to have t in 14.7 times 0.8 to the t power. Well, I'm going to start at 0. So when t is 0, I know anything to the 0 power is 1. So 14.7 times 1 is 14.7. Now I think I'll use my calculator to find out when it's 50. So I'll take 14.7 times 0.8 to the 50th power. So 14.7 times 0.8 raised to the 50th power. And I get a number that's really, really small. It's pretty much close to 0, isn't it? 2.09 times 10 to the negative 4. That's 0.002. So I think that's enough for us to do our graph then. So I'm going to say y equals, let's say 14.7 times 0.8. We'll raise that to the x power. And what I'll do is I'll adjust my scale. I'm going to have my x-axis go from 0. In fact, maybe I'll go -5. Just a little bit of a margin there. And I'll say up to 55. And then I'll have my graph go from 0 for my y to 15 for my, to 15 for my x. So I can see that. Now, if you look at your table, in fact, if I make this, oh, we don't have projector mode here anymore. We used to have projector mode to make it thicker so you could see it. But then, there's your decay model. And you can see your y-intercept is going to be 14.7. And really can't have a negative model here because we're talking about real-life scenarios. So it starts at 14.7 and goes down to 0.